everybody. My name is Winkler. I'm working for the competence center ScaDS.AI at TU Dresden. And today I'm going to talk about OmniOpt, which is a tool for hyperparameter optimization on HPC. It has been created within our project by my colleague Norman Koch and myself. First, some motivation for our subject. Of course, hyperparameters are important control parameters for neural networks, but not only for neural networks, also for classical simulations. They govern the accuracy, the efficiency, and transferability of the model. They determine the network structure of neural networks, the data flow, activation functions, optimizations, algorithms, and so on. In classical simulations, they are usually determined by fitting to measured values. And the common approaches to determine hyperparameters are grid search, random search, manual search, which are of course costly and time-consuming. So for that reason, as we have an HPC system in our institute, we decided to create an automatic hyperparameter optimization tool for a wide range of problems. It should be highly parallel on the HPC system and user-friendly. So now I'm going to talk about the special features of our tool OmniOpt. As already said, it's a hyperparameter optimization tool for neural networks and classical simulations. The use case, of course, has to be provided by the user as a black box. The user also has to deliver his objective function, according to which the problem has to be minimized. It works highly parallel on the HPC cluster Taurus at TU Dresden, which has a high number of CPUs or GPUs. It's easy to get several hundreds of CPUs and easily 50 GPUs. We use a stochastic optimization algorithm called TPE, Tree Structured Parson Estimator. We draw the software from the Hyperparameter project, which is freely available on GitHub. OmniOpt can cope with a high number of parameters, much more than 10 are possible. It has a user-friendly graphical user interface, which allows the user to communicate easily with the software. And there are also a lot of automatic features for automatic evaluation of the results and also for plotting the results. I will show some examples later. Generally, OmniOpt is a free tool for researchers and students. It's not fully automatic. The user needs to supply not only his application, but also the parameter boundaries, and he has to interpret the results in an intelligent way. So let me briefly talk about an application that we have optimized by OmniOpt. It comes from our colleague Johannes Gerritsen from the engineering department of TU Dresden. To make it short, our engineering colleagues, they want to identify material parameters for nonlinear material models. So in the lab, they measure the strain stress curves of materials, and they get curves like this. You see them here. And what they want to get out is two material parameters. They are called G0 and A in this case. And normally such a thing is done by a normal curve fitting, but our colleague Johannes wanted to use neural networks because later on he will also handle more difficult problems where up to 20 material parameters, which is too much for curve fitting. So Johannes has created a neural network. Actually, he has created two different kinds, a dense network and a convolutional neural network. And then he came to us and said, I have some fairly good results, but could we get more out of it? We would like to have more accurate results. And so we offered him to make hyperparameter optimization of his neural network by OmniOpt. So for a start, we chose 5 hyperparameters, which is not too much, but the advantage is that the results can be interpreted more easily. We chose the number of epochs, the learning rate, the batch size, and the number of filters in both convolutional layers. Here on the screen you can see the parameter boundaries. And here you can also see that the user has to invest some work. So you have to make some tests before to find out which boundaries, which intervals are reasonable. For many cases, like 1000 epochs will be a bit much, but for our case, it turned out to be a reasonable interval. The resources we used were 500 CPUs on the HPC cluster Taurus at TU Dresden, and we restricted the evaluation to 2000 sets of hyperparameters. The final wall clock time was 10 hours. And the minimum we got out, actually the objective function was the sum of the mean square errors of both parameters. So the minimum we got was at 1.5 to the power of -3, which is quite acceptable value. Here you can see at the bottom you can see the hyperparameters of the minimum which has been found by OmniOpt. And as you can see, the training process for the optimal hyperparameters, it looks quite well. Here you have the MSE for training and test data. And what is maybe even more important is that you can see here the material curves. So these are these strain stress curves, like describing the behavior of the material when some force is exerted on it. On this axis, there is a measure of the force which is automatically exerted on the material, and on the vertical axis you have the elongation of the material. So it's like a material property. It describes the behavior of the material under pressure. You can see here that the measured and the simulated values agree quite well. And our colleague Johannes from the engineering department was quite happy. Now my colleague Norman Koch, who has done a lot of programming for creating OmniOpt, he will show you how to use the graphical user interface in practice.
Hello, I'm Norman Koch. I'm a computer specialist at ScaDS.AI, and I developed the program OmniOpt, which Peter just presented to you. Now I want to show you the GUI of OmniOpt, where you can easily enter the data and how to enter the data in a very brief format. Well, first we need a project name. Let's call it lecture series. We will run it on a machine learning partition, which means we have GPUs. We can also easily disable GPUs if we don't need them. We will use 5 workers and 2,500 megabytes of RAM per worker. And we will run it for 10 hours, maximally 1,000 evaluations. We will use a 3,000 estimator instead of random search, which we could also easily choose. And here we input the path of the program that we want to optimize. let's call it my program.py. And for the sake of this presentation, I will use only 2 parameters. Of course, in your examples, you will use more parameters probably. The first parameter is called x0, the second x1, and 2 parameters. Let's use batch size as the first parameter with a maximum number of 200, and the second parameter learning rate with a maximum parameter, and the second parameter learning rate, which is a uniform parameter between 0.0001 and 0.001. And now, as you can see, it automatically creates a config file which OmniOpt uses to optimize the program, and it creates an sbatch command and also a bash command which you can easily copy into the clipboard and insert on Taurus, and then it automatically clones the Git repository and asks you if you want to start this job. And now the job has been started and you just need to wait for getting the results.
OmniOpt not only has this graphical user interface for input of the data, but also tools for evaluating the results. One important tool is an automatic plot of the results. Of course, the hyperparameter space has usually a quite high dimension. In our case, it is 5, because we have 5 parameters. And the 5-dimensional space is very hard to depict, so we chose to plot each pair of hyperparameters. So in case of 5 hyperparameters, we have 10 plots, which you can see here, and they can be easily created automatically after OmniOpt run. The dark blue values are the best ones, and the red values are the worst ones. And what you can also see here, maybe the next picture in a bit more detail, is that our algorithm, the TPE, searches in the parameter space in an intelligent way. So the places in the parameter space where there are bad values, they are almost empty. So the algorithm realizes don't look in these regions, and the regions where there are many blue dots, they are more dense. To compare OmniOpt to a standard package for hyperparameter optimization, we have performed the same problem with AutoKeras. Now, AutoKeras is a fully automatic hyperparameter optimization tool. It can be implemented typically within few lines without a big effort. However, the user has almost no influence on the choice of the hyperparameters, the borders, the type of the network used. Also, you have no influence on things like early stopping. And if you want to influence it, you have to do some workaround. But it's very easy to handle, and the computation times are very low actually. So you can, for our problem, it was possible to perform AutoKeras on a single CPU, and it lasted between 2 and 4 hours. And the mean square error, or the sum of the 2 mean square errors, was around 1.6 to the power of -2, which means that the error is 1 order of magnitude higher than for the OmniOpt result. So it means that in our case, AutoKeras was not able to find a really good result. This is not a general statement about AutoKeras. I just say that in our case, the result was, we were not very happy with the result. So now let me draw some conclusions. Maybe first about AutoKeras. It's extremely easy to implement. The computation times are moderate. No HPC system is required. But the drawbacks are that the user has very limited control over the optimization procedure, and in our case, it didn't lead to good results. OmniOpt is very flexible and versatile in use. So practically, you can optimize any problem that you have. The only restriction is that it has to be programmed in a standard programming language which runs in our HPC system. It can be C, it can be Java, it can be Python, Perl. So there is a wide range of problems. Also, the common machine learning libraries are supported: TensorFlow, PyTorch, Keras, whatever you want. An important point is that the user has full control over the whole process, so you can precisely determine what you want to optimize, what you don't want to optimize, and which special features you want to bring in. And in our case, we succeeded in finding an appropriate hyperparameter set for the problem. And but you have to consider that you have to do some work. It's not fully automatic, and that you really need an HPC system. So if you're interested to use OmniOpt, just write us. OmniOpt is a free project. You can see the email address here on the screen. Thank you for your attention.